Today we are going to make the unified stamina bar. As you can see in the bottom left hand side of the screen, we have this stamina bar. As we increase our thirst, the stamina bar decreases. As we increase the hunger, represented by orange, our stamina also decreases up until a maximum where we have no more stamina left. We're going to look at how can we implement the logic for this. We're going to make a bunch of functions and variables and talk about how the system actually works behind the scenes, how we can do the calculations. Then in the second part of the video, we're going to look at how can we implement this with the UI, how can we make these 3 different bars that progressively change size mid-runtime. We are essentially aiming to recreate the stamina bar from peak. The first thing we're going to do, I've just loaded up this default third-person template project. I haven't changed anything about it. We're going to go to the content drawer, make a new folder, and this is going to store everything to do with the unified stamina bar. So make a new folder and call it unified stamina bar. Open this up, and we're not going to create many things here. We're going to really just create 2. We need an actor component and we need a widget blueprint. Now the widget blueprint is quite self-explanatory. We need a widget, which is just the UI display, which is going to show our stamina bar. But the actor component, that is quite special, because instead of just creating it directly onto our player character, if we make it into a component, then we can add this stamina bar to any character. Let me show you what I mean. If I go to my content drawer, go to third person, blueprints, open up the third person character, in this top left hand corner, you can see there's many components. We have the mesh, camera boom, follow camera. Let's look at the camera boom. The camera boom is a component. That means in itself, all the logic for the camera boom is self-contained, and we can open any character and add a camera boom. This camera boom isn't made specifically for the character, this character, so we can use it on any other character. That's how we're going to design our component. We could make all of the logic in this event graph, but if we did that, then we wouldn't be able to easily transfer our unified stamina bar from this character to any other characters. Now, even if you're only planning on using the stamina bar on one character, it's still very good to design it in this modular way, because then if you create a future project, you can much more easily transfer the data from one project to another project. So that's why we're going to properly design it like proper programmers. So let's go back to our content drawer. Go to our folder we just made for the unified stamina bar, right click on blueprint class, and click on actor component and just call this AC underscore unified stamina bar. AC for actor component. Now, before we actually do anything inside this actor component, I'm going to make sure it's applied to our character. So I'm going to go back to our third person character and just go on components, click on add, and search for AC underscore unified stamina bar. Compile that, save that, and now we can close down the character. We just need to apply this, because otherwise, well, everything we do on the unified stamina bar won't actually be applied onto the character. Very nice. Open up the unified stamina bar and let's start talking about how this is going to work. This system is going to contain lots and lots of variables. We need to primarily track 3 different things, or 3 different types of things. We need to know lots of things about our stamina. So the max stamina, our current stamina, our stamina regen rate, etc. We need to know things about our hunger. So our max hunger, current hunger effect, etc. And the same thing with our thirst, so on and so forth. Now, we need to have primarily our max stamina, our current stamina, and our max effective stamina. That is a very, very important variable. So we're going to create it. I'm just going to call this variable max effective stamina. It's going to be of type float, and we're going to discuss what this does before we jump right into it. I could just say, okay, make these variables and do this and this and this, but I really want you to understand why we're making this max effective stamina before we start doing it, because if you don't understand it, then what's the point of the tutorial? So we need to be able to say, out of our maximum stamina, how much can we actually use? Here, I'm just in the final project, so I can show you how it's going to work at the end to better explain. The max effective stamina is the green bar you can see on the screen. Our max stamina is the length of the total bar. The length of the total bar never changes. As you can see, the orange increases, and if I press R, we get more and more blue, but the actual amount of this bar never increases and it never shrinks. That's because the maximum stamina we can have, for me I said it was 100, that's never going to change. What does change is the max effective stamina, which is the maximum amount of our stamina we can actually use. So what we want to do is we want to have a function, we'll sort that later, which is going to calculate how much of our maximum stamina we can use based off how much hunger and thirst we have. If I just ramp up the hunger and thirst to maximum, you will see we can increase the entire bar. And now if I press spacebar, I can no longer jump because that requires me to have stamina. That's a stamina cost. I don't have stamina, so I can't jump. And we increase the entire bar. But the bar's the same size, so the maximum effective stamina now is 0. So the max effective stamina is how much of our max stamina can we use. Let's go back to our new project. In order to calculate our maximum effective stamina, we also need to have a few other pieces of information. Secondly, we need to know what is our current stamina, because our maximum stamina is just the size of the bar that we can use in terms of stamina, but the current stamina is like the stamina bar within the max effective. You can think about the max effective stamina bar as the maximum and the current stamina is the current, except the maximum decreases and changes based off how much hunger and thirst we have. I'm going to give these variables a category called stamina. So inside the details panel, I'm just going to go down to category, type in stamina, and make sure these are all in the stamina category because we're going to have quite a lot of variables, so we want to make sure they're all organized. We also want to have a variable called max stamina because we need to have this fixed value that's never going to change, so we know how big the total bar could ever be. Not just the total bar for stamina, but the total bar for hunger and thirst. We're going to set this max stamina variable to 100. And we're also going to set our current stamina to 100 and our max effective stamina to 100. Everything, all these three variables so far are going to be 100 because we want to start with our maximum stamina. If you don't want to, you can change that and we'll talk about that later. But for now, we'll just say we're going to start at our stamina being full. We also want to have a way to regenerate our stamina. So we're going to duplicate the maximum stamina variable. So press Ctrl D, make a new variable and call it current stamina regen rate, and we're going to give it a default value of 1. So compile, save, go to the stamina regen rate, change it from 100 to 1. We're going to duplicate this variable and call this base stamina regen rate. Now we need 2 of these variables because, like our maximum effective stamina, so the max amount of stamina we can use, the amount at which we regen our stamina is also going to change based off our hunger and thirst. Like I said, this system, it's got quite a lot of moving parts. We have quite a lot of variables and we're going to quadruple this. But yeah, it's going to be a good system when it's all finished. We know when we start, we'll increase our stamina by 1. But that can increase, that can decrease based off of how much hunger and thirst we have. We also need another variable called increase stamina tick. Now this variable, all this does is it keeps a track of how often we're going to increase our stamina. The way our stamina regen is going to work is that every X amount of seconds, where X is this variable that increase stamina tick, we are going to trigger this function which is going to slowly regen our stamina unless we are in the middle of performing a stamina consuming action. So we need another variable to track that. So click on new variable and I'm going to call this performing action and it's going to be of type Boolean. This is going to keep track of, are we in the middle of performing an action that costs stamina? So are we jumping? Are we running? Because if we are, I don't want to regen stamina whilst we're doing it. The next set of variables we are going to want to create is the hunger variables. So let's make a new variable. Let's call this max hunger and make it of type float. Then of course we're going to make a new category for it. The category is going to be called hunger. And all the hunger variables are going to belong to this category. We're going to compile, save, and put the value of max hunger to 100. Then we're going to duplicate this, make a new variable called current hunger, and change its default value to 0. obviously we don't want to start at max hunger. We only want to start at half of our hunger. Now our maximum hunger, this is a value out of 100, and we're going to put everything out of 100 so they can all very easily fit in a ratio, a 1-to-1-to-1 ratio. However, we will have to halve our hunger effect and our thirst effect, which is the impact that the hunger and the thirst have on our stamina bar, because otherwise, you know, we don't want one hunger to take up the entirety of the stamina bar. If I'm on max hunger, I only want to lose half the stamina bar, and if I'm on max thirst, I also only want to lose half, so I have to have full of both of them to lose all my stamina bar. And because we need to keep track of that, we need to make another variable, duplicate that, and call it current hunger effect. Current hunger effect. We're also just going to leave that at 0, compile and save. If you don't really understand why we're making these variables, do not worry, it is fine. I understand it's probably going to seem quite confusing because they're not in context, but when we start using them in functions, we have to do the basic setup. We have to make them first, right? That's just slow. We have to do it. It's a bit boring. But as soon as we get to using them, I promise I will explain it again and it will all make sense. Again, we're going to duplicate this to make another variable, and we're going to call this the hunger increase multiplier. And this is a variable which is optional. You don't have to have this, but this is something I like because it means if we multiply however much we are increasing our hunger by this, we can change, you know, the rate at which we increase hunger. So for example, this might come in handy when we look at thirst. If your character is in a desert environment, you might want to have the thirst multiplier to be 1.5. So whenever you try and increase thirst, the increase is multiplied by 1.5. So you increase your thirst quicker or slower, you know, depending on the environment you're in. That's why we have this variable. We're going to duplicate this again and make another variable called hunger accumulator. Now this variable gets right into the heart of how our hunger variable and how our hunger increase is going to actually work. Firstly, we'll just put its value to 0. We don't need it to be at 1. And the way our hunger works is every 5 seconds, we're going to increase our hunger by a base hunger rate. So let's just make a variable out of that, make a new variable and call this base hunger rate. Compile and save. Every so often we're going to increase it by our base hunger rate, which is of 5. However, in between the two intervals of increasing our hunger, so you know, we do it on 0 seconds, then on 5 seconds we're going to increase our hunger again, but in between those two gaps, if we perform stamina consuming actions or hunger increasing actions such as jumping, running, we can increase how much the next hunger increase is going to be of, and that's why we add it to the hunger accumulator, which will then increase how much we add to our hunger on the next cycle. The cycle is going to also be tracked by a variable, so we're going to duplicate this variable and call this hunger tick interval, which is how often we're going to increase our hunger. I'm going to make our thirst work in a slightly different way for the sole purpose of showing you another way of making a slightly different system. I wanted to make hunger in this way, so if you're new and you have never done this sort of system before, you can get to see how it works. And if we do thirst in a different way, then instead of just copying and pasting the same code, which is boring, we can look at a slightly different system, which I think is more interesting and more educational, so there's more value out of this tutorial. Very cool. We've got our stamina and hunger variables. We're going to close those down. Now we need our thirst variables. So we're going to make another variable, keep it of type float, and call this max thirst. Of course, we're going to compile and save and put its default value, to 100, because we want all of these values to be out of 100, so we can easily compare and look at the ratios between them. This whole system is based off ratios between these different values. The category, we're going to set it to the thirst category so we can organize them all together nice and cleanly. Then we're going to duplicate this variable and call this current thirst. By the way, the reason I duplicate the variables instead of making another one is because once we've put it into the category of thirst, if I make another variable, it's not automatically in the category, so we'd have to put it into the category every time. But if I duplicate the variable, then by default it is in the category, so it's just a little bit quicker, a little bit more efficient. on our current thirst variable, we're going to set the default value to 0, compile and save. Then on this new variable, if you didn't make it, just make a new variable. This is the third one. We're going to rename this to the current thirst effect, which is the proportion in comparison with the hunger that it's going to have. This variable, understanding it now isn't super important because I will go into so much more detail when we make the function onto how it works. Finally, we're just going to duplicate this and make a variable called thirst increase multiplier. Like I said, if we're in a desert and we want to take a larger decrease or increase of our thirst at the same time, we can do that. Very nice with our thirst. We're going to set the value of that variable to be 1 because it's not going to be, 1 times more. Having this value as 1 is going to be the base because we're going to just multiply our final thirst value by this. So if we have this at 1, anything times 1 is itself. So having this at 1 just means it stays itself. If we put this to 2, then we double it. If we put it to 0.5, we half it. There's only one more variable now that we need to create. This isn't going to be in a category because it's kind of like a very important one and there's only one of them. The final one we're just going to make off the bat, it's a new variable called survival multiplier. Survival multiplier. This is probably our most important variable. By default, it's going to be 0. But this variable is going to control how much of our stamina we can use. So we're going to do some calculations to work out what is our hunger percentage of our max hunger, what's our thirst percentage of our max thirst, combine them together, find out how much of our stamina we're supposed to lose. Then we're going to apply that to our survival multiplier. Then our survival multiplier will be a value between 0 and 1, and that is going to multiply by our current stamina to decrease how much we can use. So if we set our survival multiplier to 0.5, it will halve our stamina, our max effective stamina, and then we will have our hunger and thirst combined also at 0.5. Very nice. Now we're going to make some functions that are going to use those variables we just created. The first thing we're going to make is a function to calculate our max effective stamina. How much of our total stamina can we actually use compared to how much is going to be blocked off by our hunger and our thirst. So let's make a new function and call this calculate max effective stamina. Let me type that right, max effective stamina. I'm going to put this into a category called stamina. Compile and save. Now this function by itself is going to be extremely simple. All it's going to do is take our max effective stamina and set it to our max stamina multiplied by our survival multiplier. Where is that variable? Multiplied by survival multiplier. There we go. Our survival multiplier is going to be a value between 0 and 1, and the higher it is, so the closer it is to 1, the less hunger and thirst we have, and the closer it is to 0, the more hunger and thirst we have. So imagine, our hunger is at 90% and our thirst is at 90%, then our survival multiplier might be at like 0.1. So we're going to multiply our maximum stamina by 0.1, which will give us a tenth of our max effective stamina, and that's how much we can use. We've got loads of hunger, loads of thirst, so we can only use a tenth of our maximum stamina. However, if our hunger and thirst was at 0.1 and 0.1, then our survival multiplier will be closer to 0, so it will be 0.8. So when we multiply that by our maximum stamina, our max effective stamina is now 0.8, 80%. We can use more of our stamina. The next function we're going to create is something called calculate current stamina regen rate. So go to our functions, we're going to make a new function and just call this calculate current stamina regen rate. This function again is going to be quite simple. In fact, I'm going to move this to the stamina class, by the way. It's in the stamina category. All of these functions, we're going to make quite a lot of them, but most of them are actually going to be very simple. we're just going to start combining them later on. So they're going to slowly build up and they're going to slowly start using each other. So when we make these functions now, they look very simple and they are going to be quite simple individually. They're just going to build up, work with each other. So the entire system is going to start getting a bit more complex. What we want to do in this function is simply set our current stamina regen rate, so the current rate at which we regen our stamina, by our base stamina regen rate multiplied by our survival multiplier. This works the exact same way as the last function did. The higher our survival multiplier is, the less hunger and thirst we have. Our survival multiplier will only be between 0 and 1. In fact, as a default value, we'll put this as 1. It won't matter because we'll always do the calculation first, but you know, if we have 1 on the survival multiplier, it means we've got 0 hunger, 0 thirst. So we multiply our base stamina regen rate by 1, so it doesn't get any less. Very nice. Now, I would like to make our current survival multiplier function very soon, but we need 2 values for that function to work. So we're going to quickly make 2 more functions before we can move on to it. Firstly, we're going to make a function called calculate current hunger effect. There we go. We will also have one for thirst, but I'm going to put this into a category called hunger, so it's nice and organized. And in this function, all we're simply going to do is take our current hunger effect variable, set it to our current hunger divided by our max hunger. So this is going to return, how much hunger do we have as a percentage of our maximum hunger. If our current hunger is 20 and our maximum hunger is 100, which it is, then we will get our current hunger effect as 0.2. And we'll see how that's going to work very soon when we make our survival multiplier. But we need one more function first, which is going to be calculate current thirst effect. So calculate current thirst effect. And like the last one, we're going to give this a category, this time of thirst. So it's all nice and organized. Compile, save. This is going to do exactly the same thing as the last function. We're going to get our current thirst effect and set it to our current thirst divided by our max thirst. Very nice. Very simple. Compile and save. Now we can move on to the main function, the very, very important function, our calculate survival multiplier function. So I'm going to make a new function and I'm going to call this calculate survival multiplier. I'm not going to give this a category because we only really have one function of this type, and I always want to see it on the side, or we can have 2, but it's one of the important functions, so I guess if it had a category it would just be general important. So yeah, obviously the first thing we're going to just put in is our survival multiplier. We're going to set it. I'm going to quickly grab the finished project and show you the logic so you can see what it looks like. Now I've already completed this project. The project file's on my Patreon. It's all done. Like, I've already done it before I recorded this video, so I'm just going to show you what it looks like when it works. So this is the finished project files of what this function looks like. As you can see, we've got loads of variables, loads of functions on the side. Now what this does is I've added 2 boxes which give us 2 different examples of how this is going to work. So let's look at this example here. So let's imagine our hunger is 0.8 and our thirst is 0.3. That means that our hunger, we have 80 hunger out of 100 and we have 30 thirst out of 100 thirst. So 30 over 100 is 0.3, 80 over 100 is 0.8. That's how we get the 0.8 and the 0.3. We are going to do 1 minus our current hunger effect and 1 minus our current thirst effect to sort of inverse the values. So if we have 0.8 hunger, now we have 0.2 on the effect. If we have 0.3 on the thirst effect, we've now got 0.7. The reason we're inversing these values is because if we have a low thirst effect, we want to multiply our final stamina value by a higher number up to 1. Because if you think about it, if you times something by 1, then it's itself, and the lower you go down till 0, let's just between 0 and 1, the lower you go down from 1, so 0.9, 0.8, 0.5, 0.2, the lower you go, the smaller the final value gets. So if we have a lower thirst effect, we want that essentially to have a higher number, so our final stamina isn't as low. So we're going to get that inverted value for our current hunger effect and our current thirst effect. Then we're going to add them together and multiply by 2. So we've got 0.2 after doing 1 minus 0.8, and 0.7 after 1 minus 0.3. 0.2 add 0.7 is 0.9. We add them together and we divide by 2 to get the average of them, and we set that as our survival multiplier. So if our hunger is 0.8, so if we have 80% hunger and if we have 30% thirst, then we're going to multiply our max stamina by 0.45, which means our max effective stamina will be 45% of whatever our total stamina is. And I think this makes sense because this means we get to use just under half of our maximum stamina, because it's just under half. We're timesing it by 0.5, so we're left with just under half. And if we look at our hunger, well, we've got 80% hunger and we've got 30% thirst. So in total, we've got 110% of this effect. So, you know, if we've got 80% hunger, 30% thirst, we're going to lose a little bit over half of our stamina. Now we can also look at this example just in case it doesn't make sense with a different one. If we have a higher hunger and a higher thirst, we can see what happens if our thing gets even lower. If we have 0.9 hunger, so 90% hunger and 70% thirst, when we do 1 minus these values, we get 0.1. 1 minus 0.9, 1 minus 90% is 10%, so 0.1, and 1 minus 70%, so 1 minus 0.7 is 0.3, 30%. Add them together, 0.4 divided by 2, 0.2, and then if we do our total stamina divided times by 0.2, which is 20%, we get 20% of our total stamina, which means our max effective stamina will be 20%. If you get the final projects on my Patreon, I've color coded and commented, you know, a bunch of the functions, so if you're struggling to understand it, you will be able to see what's going on with little examples and just extra comments here and there. Let's get back to our actual project we're working on. As we looked at in our little example before, we want to get our current hunger effect and do subtract, and we want to do 1 minus this value. So I did subtract just so I could get the float version of it, but I'm going to click on Alt and drag, I'm going to click Shift, Alt and, so Shift and drag will drag the pin and duplicate it. Alt and click will delete it. It doesn't matter, to be honest, that doesn't matter. Just make sure this is on the bottom because we want to do 1 minus the value, not hunger effect minus 1. We want to do 1 subtracted by the current hunger effect, so it essentially inverts it. You know, if it's 0.3, we get 0.7. If it's 0.8, we get 0.2. It just finds the corresponding number which it would add to make 1. We want to do the exact same thing with our thirst. So I can just search the value. I can just say current thirst effect and just get current thirst effect. Duplicate this pin down here, do 1 subtracted by current thirst effect, and then like we said, we're going to add them together and divide by 2 so we can get the average of both of them. We do this so that respectively each of them can only take up 50% of the bar. That's why we add them together and divide by 2, because otherwise if we had maximum hunger and 0 thirst, we could still lose 100% of our stamina bar. I don't want that to happen. I think if we've got 2 values that affect our stamina, each of them can only do up to 50% of a loss. I think that's how it should work. If you don't want that to work like that, if you want, you know, hunger to be able to do a lot more, then you don't have to do this divide by 2. But I only want it to take up 50% at most, so I'm going to do that divide by 2, plug it into our survival multiplier, compile, save. Very nice. Now we've created some functions to calculate our survival multiplier, our hunger effect, all these things. We now are able to find this value, which is going to affect our maximum stamina to find out our current effective stamina. But we can't really use these functions yet because they kind of just function sitting there. We need a way to apply them to what we're doing. So we need to find our hunger, we need to find our thirst, and then we actually need to tie it all together in a use stamina function. So let's close all of these tabs. We don't need them for the moment. And I deleted it before, but I'm just going to right click and search for event begin play. And off of this, I'm going to drag off and say set timer by event. Very nice. Now, this is going to be for our hunger, which is going to increase our hunger. Now, we also need a corresponding event that we can plug into this timer. So I'm just going to come over to the side, find a bit more space, right click, search for custom event, and call this apply hunger tick. We'll go back over and explain how the other one works. I just needed an event I could use an example to set this up. So back over here, after our event begin play, we are going to drag off of this event and search for create event. And I'm going to click on select function and just search for apply hunger tick. What create event does is it just allows you to reference any event that is anywhere in the event graph. You could optionally drag the custom event over and plug in this little red box into the event box. That works exactly the same. But if we say create event and then apply hunger tick, I just think it looks cleaner because now I can drag the event over to we've got a lot more space. But it does the exact same thing. This is just referencing this custom event and it's just going to play that custom event. That's all it's doing. We want this to be looping because we're going to want this to, keep happening over and over again. And the time is going to be our hunger tick interval. You see, this event is going to be the event that increases our hunger amount. It's going to fire every 5 seconds. This is 5 because we set our hunger tick interval to 5, but you could change it to 3 or 7. It's going to fire this amount of often on this variable, and it's going to fire this event, and it's looping. So every 5 seconds, we are going to fire this apply hunger tick event. For good practice, I'm going to promote this to a variable called hunger tick timer handle. Hunger tick time handle. Now, technically, I'm not actually going to use this variable, so I don't need it, but you should always promote these to variables so you can later reference the timer handles because, unless you have already made your entire system already and implemented it into your game, you don't know if you're going to want to use it or not. So good practice to promote that to a variable. Now we're going to handle what does handling this hunger tick actually do. What does applying hunger tick mean? What does that function do? How can we actually increase our hunger every single 5 seconds? So we're going to go over to our hunger tick event, and this isn't going to do too much actually. It's going to increase our current hunger. It's going to set our hunger accumulator to 0, and then it's going to increase all of our stats. It's going to do a stat update. Now, that might not make sense because we haven't yet made the function, but later we're going to make this function called stat update, which is essentially going to make sure that every single time we update our hunger, that we redo all of these functions up here. In the top left, I'm just scrolling my mouse over the calculate max effective stamina, calculate hunger effect, thirst effect, all these functions we just made that calculate the survival multiplier ultimately based off of these values. Every time we want to change our hunger, we need to recalculate this survival multiplier, because if our hunger is different, then our hunger effect is different, and if our hunger effect is different, then our hunger effect added to our current thirst is different, so our multiplier is going to be different. So we need to recalculate that every single time we have an update. We'll make a function for that in a few minutes. But yeah, that's all this function is going to do. We're going to increase our hunger, set our hunger accumulator to 0. The hunger accumulator is how much extra hunger we're adding, because we might have done lots of physical activity or something between the two time intervals, and then we're going to do a stat update. We need to make a new function. It's going to be a hunger function called increase current hunger. When I said it's going to be a hunger function, what I meant is we're going to add it to the hunger category. So call it increase current hunger and add it to the hunger category. This function is very simply going to take an input of the hunger we want to increase, So we'll just call this hunger to add. It's going to be of type float, obviously, because our hunger is a float. Compile and save, and it's going to set our current hunger to our hunger to add, added to our current hunger. But before we just input that, we need to do one little thing. We need to say clamp float, and then input as the maximum value, our maximum hunger. Then we can put that in. Now what this clamp does is it means if we are adding like too much hunger to our current hunger, then we will make sure it doesn't go over our maximum hunger. Imagine our maximum hunger is 100 and our current hunger is 90. If we try and add 20 to our current hunger, well, that gives us a value of 110. And our maximum hunger is 100, so if we went over 100, this clamp would snap that value back to 100, so nothing can go over that 100 maximum value. Now let's just compile and save to make sure that's all done. Go back to our event graph. Now we can use that function and we can apply it. So let's drag it into the event graph, increase current hunger. Now the hunger we're going to add is our base hunger rate added to our hunger accumulator multiplied by the hunger increase multiplier. Now that's a lot, or it sounds like a lot, but I will break that down and kind of explain what's going on. So our base hunger rate is the base amount of hunger that we want to add every 5 seconds. Remember, this function is firing every 5 seconds, or however long you've set this hunger tick interval to be. So every 5 seconds, as a minimum, we want to add this amount. But let's say, you know, our character is doing lots of actions. He's jumping, he's running about, he's doing combat, he's doing actions that consume stamina. Then we will add that to our hunger accumulator. When he jumps, we will increase the hunger accumulator. And then let's say, you know, every time he jumps, we want to increase the hunger accumulator by 1. So if he jumps twice within the next 5 seconds, the hunger accumulator would be 2. So the base hunger rate of 5 added to 2 is now 7. So now we're increasing the hunger by 7 instead of just 5. The hunger increase multiplier by default is 1, because if we times 7 by 1, well, we just get 1. So if we want to increase our hunger, we could set this to 1.5. So if this is 1.5, then we do 7 times 1.5, which is 10.5. And then we'd add extra. I'm going to leave this as 1 for now, but you know, if you wanted to say like your player increases hunger more quickly under certain effects, that's how you can do it. You can increase your hunger increase multiplier to change how much you increase your hunger by. Now, after we've done this function, we need to add a set hunger accumulator to 0, because this hunger accumulator only wants to track how much has been done in the last 5 seconds. So every apply hunger tick, we're just going to reset this so we don't, you know, add too much hunger every single time. It resets. You know, otherwise we could end up adding 50 to every single hunger after we've, you know, gone through 10 ticks or so. Now we're going to make that stat update function. So we're going to make a new function, call it stat update. And this is another really important function that does a lot for us, really, and we're going to use it quite a lot. It's going to make sure we recalculate all of our values so that our current maximum stamina is always updated, right? We've just increased our hunger, which, you know, by knock-on effect should change our max effective stamina. So we need to trigger an event which is going to redo all those calculations we did before in all these functions up here in the top left, so it's all nice and ready. For the UI, we'll handle the UI implementation in the second half of the video. So I guess once we've done this logic, the second half isn't really the second half. It only takes 10 minutes or so to implement the UI once we've done all the logic. The logic is what takes the longest. So after this stat update, what do we want to do? Well, we want to calculate the current thirst effect. We want to calculate current hunger effect. We want to calculate the survival multiplier. Add that in. We want to calculate stamina regen rate, calculate current stamina regen rate, and we want to calculate max effective stamina. Very nice. The order is important. The order is important because if you think about it, when we calculate our max effective stamina, In this function, we're basing that off our survival multiplier. So our survival multiplier needs to be updated before the max effective stamina. But when we update the survival multiplier, we need to know the current thirst and the current hunger. So we need to update those two variables before the survival multiplier, so that's up to date. So the logic is important. These two could be in either order, the thirst and hunger, that doesn't matter. But apart from that, these three need to be in this order, because it, you know, the current stamina regen rate, that needs the survival multiplier. So it has to come after we have updated the survival multiplier, obviously, because it needs to know that new variable. One little problem that could arise, and did arise when I first made this project, as obviously this is the second time I'm making it, is if we had our max effective stamina at 90 to start with, then we moved it to 80, it doesn't properly update because we aren't snapping our max effective stamina to the new max effective stamina when it's been updated. So I'm going to make another little helper function, so make a new function, and I'm going to call this snap stamina to max effective. And it works, it's a very simple function. Remember how, on the event graph in this increase current hunger, we just use this clamp float to make sure our new hunger didn't surpass the maximum hunger? Well, this is going to be very similar, right? We need to make sure that our current stamina isn't going to surpass our max effective stamina, because in our stat update, if we have 90 stamina, then we update all this to make our new max effective stamina 70. Well, we've got 90 stamina out of 70. Well, that doesn't make sense. We need to change how much current stamina we have. So inside this function, we're simply going to do a branch, which is going to check, is our current stamina, so go to the stamina category, is our current stamina greater than our max effective stamina? We do the branch because if our current stamina isn't greater than the max effective stamina, then there's no problem. We don't really care, right? That's normal. But if it is, if we've got too much stamina for our max effective stamina, remember the max effective stamina is how much of our stamina we can actually use, then we need to set our current stamina to our max effective stamina to sort of snap that variable, clamp it, and make sure it's not too much. Close that down. In our stat update function, we're just going to put in the snap stamina to effective, put that into the stamina function section. Very nice. Compile, save, go back to event graph. Now we're updating our hunger. Actually, we need to add the stat update function. That would be helpful if we did that. Now we've got the stat update function. I'm going to add 2 keyboard button presses to either increase our hunger accumulator or decrease our current hunger, so we can see how these would work. So down here, I'm just going to right click and search for keyboard event H, keyboard event H, and keyboard event J. Now, in an actual game, obviously you wouldn't have these functions, but I'm just adding these so I can show you how this is going to work. Off of this, I'm just going to search for increase hunger accumulator. We don't have that as a function yet. So increasing our hunger accumulator, I made it as a function, but it very, very simply just gets our current hunger accumulator. So where is it? Hunger accumulator. It sets it to our however much we want to add, plus our hunger accumulator. So I'm going to drag over this to highlight it, right click and press collapse to function, and I'm going to call this increase hunger accumulator and add this to the hunger category. I'm going to double click, open this up, give it an input of hunger to add. So this is how much hunger we're going to add. And well, whatever that is, we're going to add it to our current hunger accumulator, plug that in there, compile, save it. That's all we need to do. We don't need to clamp this because there is no maximum for our hunger accumulator. You could if you wanted to. In fact, I think we will clamp this to our max hunger. so our hunger accumulator could never be larger than our maximum amount of hunger, but we don't have in itself a maximum for our hunger accumulator. You know, up till our maximum hunger, obviously, we could have any amount in the accumulator, even if it's a very large amount. Back into event graph, we're going to just change this value to 2.5. Just, you know, so we've got a value and we can see what's going on. And when J happens, we're going to decrease our current hunger. So of course we need to make another function for that, just called decrease current hunger. We don't technically need a function for this. You could just have it in the event graph itself, but I think if you make a function for it, it makes everything a lot more organized. And also you can then call that function from a different actor. So if you wanted to apply this component to our third person character, so it's just, you don't need to do this. I'm just going to show you how it, like a little demonstration, but you don't need to do what I'm doing right now. So I'm just going to go to our third person character, right? If I I don't know why it went on the wrong, where's it gone? That was weird. It kind of like opened, but on my second monitor. Anyways, we have the unified stamina bar. We drag it in, and I can search for decrease current. There we go. Very nice. We can access this function from the unified stamina bar. If we just said, you know, get hunger, set it to hunger decrease, blah, 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 with no function, we couldn't just easily call it from here. But by doing this in a modular, reusable way, it becomes modular and more reusable. You know, we've just done more for the system, so it works better. In this decrease current hunger, we're going to add a float input, which is called hunger to remove. This is the amount of hunger we're going to take off of our hunger. So we're going to set our current hunger to our hunger to remove, or rather our current hunger subtracted by our hunger to remove. So remove that hunger to remove from our current hunger. And we're going to clamp this, clamp float, this time to make sure it doesn't go below 0. I'm going to put into the maximum or maximum hunger, just because that makes sense, but you could have put that to a very large number. The point of this clamp is to make sure when we decrease our hunger, we don't go into negative numbers. We don't want to have negative hunger, at least not in my system. I don't think that makes sense. We're going to add the decrease current hunger to our hunger category of the functions, drag this in, we'll just, you know, put that to 5. And afterwards we have to call stat update. Because we just decreased our hunger, this means that we can now use more of our stamina bar, and to be able to calculate that, we need to call this stat update function to update all of those values. Comment all this and just call this hunger, so we know that this is our hunger section. Very nice. Compile and save. Now we're going to move on to thirst. In fact, let's make one small change. We'll move this stat update inside this function. So we'll call stat update at the end of this function, because we know every single time that this happens, we will want to update our stats. So we'll just make sure it automatically happens. There's no need to have it happening after, because like I said before, if we called this from BP underscore third person character, then having this in the function would mean it all happens in one go. But if we had it outside the function, then the player would also then have to go off the end and then call stat with themselves, which just doesn't really make sense. It's just inefficient. So that's just a better way of doing things. A little bit further down, I'm going to right click and search for keyboard event R and keyboard event T. I'm going to do this thirst system in a slightly different way. This is probably the classic thing you'd expect, right? We press R, we increase thirst. We press T, we decrease thirst. The reason I'm showing you both of these systems, I mean, I could have just very simply done, you know, increase, decrease on 2 button presses for hunger, but I just wanted to show you how we can set this up in just a more interesting way, really. Because in a video game, you won't always want it to happen every single time an action fires. You might, you know, want your hunger to always be increasing, not just when certain actions fire. So I think that's just more educational value. Yeah. So every time we press R, we want to increase our thirst. So by now, this should be screaming at you, new function called increase thirst. Let's make a new function. Call this increase thirst Very nice. Open this up. In this function, we need an input called thirst to add. Thirst to add. This is how much thirst we're going to add to our current amount of thirst. And very, very simply, we're just going to, like before, set our current thirst to our current thirst added to this new amount. And we're going to clamp it to the max value so we don't surpass, too much. We don't surpass the maximum thirst we could have. So thirst, add to this input value, clamp it to the maximum thirst and 0, input that, and then call the stat update function, because if our thirst changes, if we increase our thirst, we want to decrease our max effective stamina. So we call stat update, so it updates all those functions, does all those calculations, very nice and clean for us. I'm going to move this to the thirst category, and I'm simply just going to duplicate the function, so it's going to be a little bit quicker. So increase thirst, I'm going to just press Ctrl D and rename this function decrease thirst. This input thirst to add, I'm just going to call this thirst to remove, and then we're going to actually I didn't need to delete all of that. What we're going to do is take this thirst to remove, get our current thirst and say subtract by the thirst to remove. So our current thirst subtracted by thirst to remove is going to be clamped between 0 and our maximum thirst. So it's never going to be a negative number, and it's never going to be more than our maximum thirst. And again, we're going to call stat update. So now in our event graph on R and on T, we can just add these events. So when we press R, we're going to increase our thirst. Let's just say 5. When we press T, we're going to decrease it. Again, let's just say, oh, I didn't mean to open the function. Let's say 5, right? I think that's a nice value. Why is it not highlighting? There we go. Compile and save that. Very nice. I'm going to comment this. So highlight everything, press C, and I'm just going to call this thirst, show bubble when zoomed, and color bubble. Very nice. Now we can see it all. Now, the next thing we're going to start doing is our stamina, right? We've created this hunger, this thirst. We've got all these calculations going, all these functions which will calculate our survival multiplier, so we know how much to decrease our max effective stamina by, but we haven't actually done anything with our stamina. We haven't made these functions to increase or decrease our stamina, so let's do that now. We're going to make two functions. We're going to make a decrease stamina and an increase stamina function. So let's go to our functions category, plus, and call this decrease stamina. I'm going to move this to our stamina category. Very nice. Compile, save, and we're going to give this a float input called stamina to decrease. Very nice. Now this isn't just going to increase or decrease our stamina. When we decrease our stamina, we also want to return a Boolean value called success. So I'm going to click on output. I'm going to call this success, and I'm going to make this of type Boolean. You see, the way this works is we actually call this function, when our player wants to jump, right? Jumping is an action that will cost stamina. So when the player wants to jump, they call the decreased stamina before they jump, to not just decrease the stamina, but to check if they have enough stamina to be able to decrease. Because if they don't, then they're not allowed to do the action. If the player doesn't have enough action to jump, then they're not allowed to jump. So we need to check if the player's current stamina minus this amount of stamina that's going to decrease is greater than or equal to 0, then they can go ahead with success as true. But if it's not, well, then they're not allowed to do the action. So we're going to return with false. So I'm going to add a branch in between these two, and I'm just going to duplicate the return node and put it to false. Because what we're now going to do is get our current stamina, and we're going to subtract the stamina to decrease, and we're going to say greater or equal to 0. Plug that into the Boolean. Now, this is very careful here. Be very careful. This isn't updating our stamina. It's not. it's minusing this from the current stamina, but the current stamina value has not changed because we haven't set the new value. We haven't brought this in and said set. So the current stamina here has not changed. All this is a check to see if we minus the stamina from our current stamina, is that greater than 0? It's just a check to see, you know, what would happen if we did it. And if we did that subtraction and it was still greater than 0, then on true, we can set our current stamina to whatever this value returns. So this subtraction, now we can set it to our current stamina after the boolean on the true pin. But if it's false, that means we're not allowed to do that action. We don't have enough stamina. In that case, we do not want to update our stamina because, you know, we're going to return false, which blocks the player from doing the action. So then there is no need to decrease stamina because nothing has actually happened. Cool. We're going to duplicate this decrease stamina function and call this now increase stamina. So we've got our increase stamina function. Of course, we need to do a little bit of editing, and we don't need exactly the same. We can get rid of, well, we can get rid of everything really. The only thing we need is just this input of stamina. We don't need an output. You can get rid of that output. We are going to set our current stamina to our stamina added to our current stamina. Add this inputted stamina, and of course we're going to clamp float to 0 or the maximum, which is going to be our max effective stamina. It's not our max stamina because the max stamina is the length of the entire bar. The max stamina is what we have if you've got 0 hunger and 0 thirst. But because our system, you know, is going to decrease the amount of stamina we can use, we need to do it against the max effective stamina, because the max effective stamina is, you know, how much of our stamina can we actually use. So make sure compile and save that. We can close these functions now. And I'm going to go to our event begin play, and we're going to make another timer, just like before, to increase, you know, how much stamina we're gaining every second. We're going to add this like we did with the hunger, you know, another timer to gradually increase our stamina over time, unless we are performing an action. Remember, we made that boolean variable to check if we're performing an action or not, a stamina costing action that's implied. Yeah, very similar to this one before. If you understood what we did here, this next one should be a breeze. We're going to drag off here and say set timer by event. Just like before, we're making a new timer which is going to run an event a certain amount of times. The event, we're going to drag down here and search for custom event. You could optionally make the custom event further away, search for create event, and then plug it in like we done this one. But I showed you how to do that before. If you want to do it, you know how to do it. We did it earlier in the video. Now we'll just do it like this because it's quicker and easier. I'm going to call this stamina tick regen. This is going to be looping, and the time is going to be our increase stamina tick. This is just a variable which has a value of 1 because we set it to 1, which means every 1 second we're going to run this stamina tick regen. Now what this is going to do is it's first going to do a branch which is going to check, are we performing an action or not? So we're going to drag in get performing action, and we're going to say not boolean, and I'm going to plug this into here. Now, the reason I've done a not boolean is simply for stylistic preference. I think it looks better if, you know, our positive event runs on true, right? The thing we want to happen runs on true. I just think it looks cleaner. You could optionally just put in performing action and do this on the false pin. This not boolean is not necessary. I just like using it because then it means I can continue my execution on true, which in my head always makes sense, right? The thing you want to happen should happen on true, if you've only got one out of true or false happening. So on true, we're going to use our increase stamina function, which is going to increase our stamina by, let's just say 5. Right, just a default value. We're going to increase our stamina by 5 up until our max effective stamina. Compile that, save that. Very nice. I'm going to comment this, so highlight all of it, comment, and call this stamina tick just so we know this part is specifically the stamina. And if I move event begin play out of the way, I can comment this as well and call this hunger tick. Trouble when zoomed, color bubble, compile, save. Very nice. Now what we're going to do is we're going to apply our stamina increase, decrease, and check if we've got enough to our third person character so we can see how it's actually going to work. First, I'd like to create one function. We don't technically need this, but it is a nice thing to have. It does make our lives easier and quicker. I'm going to make a new function. I'm going to call this update performing action variable. Now, all this is going to do, it's very, very simple, is going to take our performing action and set it to an input, to a Boolean input, which is going to be called, performing action, right? This is performing a stamina action. It's going to set it. That's all it does, right? We take in a variable and we set it on this one, but I like having it in a function because then it's a lot easier and cleaner and more readable to use when we do use it on the third person character. So when we open up our third person character, we're going to come down here to our jump. Now I'm only going to do this on jump. I'm only going to do it once because when you know how to do it once, it's the same process every time. You could also do this with move in your game if you have like, I don't know, a sprint function, if you have a dash function, you can do the same thing in the same way with all your different things. So we'll do it once on jump, then you'll know how to do this. Idea of checking if we have enough stamina, playing it if we do, and not playing it if we don't. Yeah, so let's get into it. Right, let me just move this stop jumping down here and jump over here. So we made this decrease stamina function to work in such a way where we actually run this before we run the event. We don't jump and then decrease stamina. We decrease the stamina and then jump, because the decreased stamina also checks for us if we have enough stamina to allow that action to happen. So we can drag in our AC unified stamina bar. Off of this, we can say decrease stamina, plug that into started. In fact, I will press shift and drag onto that one, and then it drags both of the execution pins at the same time. So it's plugged into started on that and jump on event touch jump start. The stamina decrease, for example, we'll just say 5, right? I'm saying the cost of a jump is going to be 5 stamina, and off of this success, we're going to do a branch. Now, what this means is if we have enough stamina to jump, then we will do a jump. Very, very simple. And whilst we're jumping, we want to drag in the AC unified stamina bar and say update performing action variable and set that to true. This means that on our event tick, how every 1 second we update our stamina, we're no longer going to update our stamina because this is going to fire as false because we are now performing an action. So whilst we're jumping, we're not increasing our stamina. So when we stop jumping, we can duplicate this down here and say set performing action to false. We're no longer jumping, we're no longer performing an action. That variable can be false. Very good, very nice. Go back to our stamina bar. Now we've just made all the logic for the system. That is the logic side of the system done. We are now going to start working on the UI display. However, we've just done what, about an hour, maybe a little bit more worth of work, and we haven't actually checked it. I know it works because I've done this before, but when you're making this on your end, you might have made some mistakes. You might not have done everything I did. If you've copied every single thing that I've done up until now, it will work. But that is very unlikely. Well, not very unlikely, but often, you do make mistakes when following a tutorial. You drag in the wrong function, you forget to plug in an input. Something can happen. So let's just add a little test that we can do to make sure our system's working before we proceed with the UI. Let's drag over, find a bit more space, and let's just search for event tick. Now, I must stress, this is not a permanent solution for, displaying the system. This is strictly for testing purposes, and you will remove this in your actual game. I have just added a bunch of print strings. I did it off camera because it would take like 3 minutes to do it and there's no need to waste your time. because it's the same thing, right? I've done a print string and I've just dragged off this, said append, so I can put in two different parts at once. So drag off this and search for append, so you can put in two parts of the string. Then I've just said current hunger is, and then I'm printing the current hunger. I'm saying current hunger accumulator is hunger accumulator. Doing all of this, I've color coded it as well, so the different strings have different colors. But, you know, I don't think I need to tell you how to do a print string, right? If you followed the tutorial up until now, you should be okay with a simple print string function. Let's plug that return value back in. Okay, so very ironically, I actually did have a small mistake. I pressed play. From this point, if you have copied every single little detail, you will have one small error. And that is because in the calculate survival multiplier function, here where it says current thirst effect, I had inputted current thirst instead of current thirst effect. So I was doing current 1 minus current thirst, which was giving me a really big negative value, and I was getting really weird results. So if you have current thirst inputted into this part, 1 minus current thirst, then it won't work. Make sure it's current thirst effect. That was just a mistake by me. I accidentally put in the wrong variable. It's very easy. It happens to everyone. I mean, I've already done the project, right? It's on my Patreon. I've done it already. So I shouldn't have done that, but it happened. So yeah, now everything works though on my end. Everything works now. I get loads of people always saying to me, oh, I've copied every single little detail up until now, it doesn't work. Sounds like they're expecting me to, you know, say, oh, I'm sorry, I didn't do something, you should do this extra, blah blah blah. No, I've done every little bit on camera, even that little correction there. I just told you every single thing has happened. So if you've done everything the same, the only thing I didn't do on camera was importing these, but that's print strings, right? That should be fine. Now if we play, you can now see in the top left, just look in the top left, go to the very top and look at where it says current max effective stamina, then go down the lines. So current stamina, current survival multiplier, current thirst, current hunger accumulator, and current hunger. Where it says current max effective stamina again, that second one we don't care, right? It's repeating the same variables. So if we just look at the top, what is that, 6 lines? That's what we need to look at. As we can see, the current max effective stamina is slowly decreasing because our current hunger is increasing, right? We go from 30 to 35, and our current effective goes from 85 to 82.5. That's correct. But now if I press J, our current survival multiplier increased again, and our max effective stamina has increased. Our current stamina is 100. I'm trying to jump, pressing jump, 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 jump. Now it gets to 0, and I can't jump anymore. Gets to 5, I can. But when I'm at 0, I can't jump. If I increase my thirst with pressing R, you can see my current max effective stamina decreases. And if I press H to load up what I'm going to get on the hunger, as you can see on the next tick, now my current max effective stamina is 25. This is going to decrease in a couple seconds. There we go. And it also decreases my current max stamina. So yeah, our system is 100% working. The logic is working. Everything is fine. As we can see, all the variables are coming out exactly as intended. I'm going to unplug the event tick now. The next step now, what we're going to do is, well, firstly, let's just comment this and just say event. Oh, let's just call this event tick debugging. There we go. Now the next step is the UI. How can we make this show on the screen? How can we have a little bar in the left hand side showing us exactly what to do, or rather exactly how our stamina is? You know, how are we going to do that? This is just the finished project files now. Again, you get the finished project files on my Patreon. As you can see, we have the bar, and we can see the size of the bar never changes. But when we increase our hunger or our thirst, the size of the other bars change, and this one is decreasing. Now, the whole idea behind this, how this works, is we have this unified stamina bar, this widget, right? It's one horizontal box, and the horizontal box is a fixed length. This is 500 units long. That 500 units never changes. All we're going to do is we're going to take these three boxes that we put inside the horizontal box. We've got 3 size boxes, and we change the size of the size boxes on a ratio. So we're going to do some calculations, we're going to do some maths, we're going to create some more functions to basically calculate what is the ratio between our stamina, our hunger, and our thirst. And then simply we're just going to change the width override of each of these boxes in accordance with that ratio. So we'll do 500 times whatever their part of the ratio is and set that to the size box. So it will change the width override of the size box, change the width, and it will go back into the correct position. As discussed, we need to now make a function which is going to calculate the ratio between our effective stamina, our hunger, and our thirst. So let's go to our AC underscore unified stamina bar, make a new function, and I'm going to call this calculate bar ratios, because this is going to be the ratios that each I guess thing is going to fill of the final stamina bar. I am pretty sure this is the last function we're going to make. I've got like a note tab on the side which is telling me what thing to do at what time, so I haven't seen right till the end, because I wrote out my steps as I did the first time. But yeah, I'm pretty sure that this is the last function we're going to do in here. We'll see. But there's not one left. Anyways, so local variables. We need a few local variables for this function. We could make them as normal variables, but the thing is we're only going to use these things inside this function. We don't need to know about them outside the function. So yeah, let's make them local variables. Because a local variable is a variable that you only can use inside the function. You can output them, so you can, like output it to the function. So when you call the function, you can get a reference to the variable. You can, or rather, promote that to a new variable. But the variable itself cannot be referenced from outside of the function if it is a local variable. We need 4. We need the effective stamina ratio. So let's make a new variable called effective stamina ratio. That's the ratio of our effective stamina. We need blocked ratio. Blocked ratio. I'll explain what that is in just a second when we've made the two others. We need hunger ratio, and then of course thirst ratio. Now we're doing something called blocked ratio because we want to start with just find the ratio between our effective stamina and X. Now X is our hunger and thirst put together, but I'm just going to call it X because that's easier to think about, right? But remember that X is hunger and thirst, it's just anything that isn't effective stamina. We need to know how much effective stamina do we have and how much X do we have. We don't care about hunger and thirst for the moment. We're just finding out how much effective stamina do we have, right? How much of our bar is our effective stamina. And we can do that like rather, simply. We can say set effective stamina ratio to our max effective stamina. So let's right click, search for get max effective stamina, and divide that by our max stamina. So divided by max stamina. Yes, get max stamina. So this is going to return a value between 0 and 1, right? If we have 50 max effective stamina and the max stamina is 100, then that gives us 0.5. And that's going to be our ratio for our max effective stamina. We want all of our ratios to add to 1. And that's why we have this blocked ratio. So we're going to set our blocked ratio to our effective stamina ratio. And we're going to do subtract. Plug that into the bottom pin and say 1 minus. So 1 minus our effective stamina ratio is our blocked ratio. Now, what this means is our entire bar, our entire stamina bar is 1, right? The ratio, all of it is going to add up to 1, which makes it very simple for us to find out what percentage does each part have. So when we find out how much is our max effective stamina of our max stamina, let's say 70%. If this is 0.7, then our max stamina ratio is 0.7, which means the effective stamina is going to take up 70% of the bar. Well, if that takes up 70% of the bar, well, if the total bar is 1 minus 0.7 or 70% is going to give us 0.3, and that's how much the rest of the bar is. It's going to be 1 in total, and if you've got 0.7, well, 1 minus 0.7, 1 minus 0.7, that's why we do that here, is going to give us the ratio. Here I've called it blocked ratio, but that just means the rest, right? What else is there? You know, the ratio of the stuff left over. After the set blocked ratio, we can say set hunger ratio and set thirst ratio. Now I'm gonna move these out to the side a little bit because we're gonna need some room. Things are gonna get a little bit intense, right? We're gonna get some calculations going on. We need to find out how much of this blocked ratio is our hunger and how much is thirst, right? We know how much is left. How are we going to divide up what's left into hunger and thirst? That's what we need to think about. So just compile and save, just because the button I hate when it's yellow. Like whenever I see it and it's yellow, I always click on it. It just, I don't know, it gets me. Anyways, so take out the blocked ratio, add a reroute node, and I guess the idea really is to find out how much hunger do we have. What's our percentage hunger, right? Like out of our maximum hunger, how much hunger do we have? If it's 50 out of 100, it's 50%, right? And find out how much thirst we have, and then add those together, and then divide those by the total. Now, it's kind of hard to explain without showing you, so I'll show you first, and then we'll go through it again. We want to get our current hunger, so get current hunger would help if I could spell. We want to divide this by our max hunger to find out, you know, what percentage of our maximum hunger do we have, how hungry are we, and then we also want to do the same with thirst. So we'll say get current thirst, get max thirst, and divide. So how much of our max thirst do we have? What proportion of our max thirst do we have? Then we want to add those two together to find out what's the total of both of these. And then if we go to our current hunger, right? So let's say this is 0.7 and this is 0.3. Then this is 1. Our total ratio of this is 1. And if we do a divide after this first division, drag off a divide and put it over here, divided by this result, then we can find the ratio of our, you know, new max hunger ratio over our hunger added to max thirst. So imagine this is, you know, what our hunger percentage is. This is what our thirst percentage is. We add them together to find out like the total percentage of all the negative effects we have. Then we can find what percentage of those negative effects are hunger. That's what this division does. This division is saying how much of this, how much of the total negative stuff we have is our hunger negative effect. And then if we do another division down here, another divide down here with this plugged into the bottom, because it's this negative effect of thirst over total negative effect, and this is, let's just comment this, so this is total negative effect, this is hunger, and this is thirst. So we want to do thirst divided by total negative effect to find out how much of this blocked ratio, this is going to give us a percentage, how much of the bad stuff we have is our thirst, and how much of the bad stuff we have is our hunger. Now we have this ratio, we can multiply it by the blocked ratio and set that into hunger. We can do another multiply it by the blocked ratio again. I can just drag this off of here, reroute node up here, just add some reroute nodes so it like looks a bit cleaner, and plug that into the thirst ratio. I think this is probably the most complex part of the system. It is quite confusing, so I'm going to go over it once more. You know, if you understand it, just, you know, skip ahead at like 30 seconds or something. But if you want to hear me go through it again, then let's do that right now to try and clear things up. So we are calculating, how much of the bar is our max effective stamina, how much is our hunger, and how much is our thirst. Well, to start off, we know that the bar is always going to be a total of 100%. What that means is when we start the game, our bar is going to be 500 units long. It's never going to be more or less than 500 units. It's never going to be 105%, 95%, 50%, whatever. It's always going to be 100% of its initial size. The size isn't going to change. So we've got 100%. We know that 100%. We can also write that as 1 over 1, or just 1.0. Right, 1.0 for a ratio, because 1.0 out of 1.0 is just like 1. It's everything. So if we get our maximum effective stamina and divide it by our max stamina, we know our effective stamina ratio. Effective stamina ratio just means out of this 1 that we have, how much is our stamina, right? If our max effective stamina is 80 and our maximum stamina is 100, so this is going to return 0.8, which means our effective stamina ratio is 0.8, so the max effective stamina takes up 0.8 of the bar. We know that our hunger and thirst combined is going to be equal to 1 subtracted by whatever this is. Now what that means in I guess words is we're filling up 80% of the bar with this part. So if our bar never changes size, we know that whatever the remaining proportion is, it has to be the remainder of whatever our total is subtracted by our effective stamina, because we've got the same amount all the time. So we can find out how much is left for hunger and thirst combined by doing 1 subtracted by our effective stamina ratio. So if this is 0.8 and we do 1 minus 0.8, we get 0.2. So we know whatever's left is 0.2, and we've got 0.2, so 20% of the bar to divide up between our hunger and our thirst. Now we need to find out, how are we going to divide that up? How are we going to set our hunger ratio and our thirst ratio to cover that properly? Well, we need to find out how much, I guess, of a total negative effect do we have, and we can divide each individual negative effect by that total to find out what percent of all the blocked ratio, all the bad stuff we have, is hunger or thirst. So if we get our hunger ratio, if we find out how much hunger do we have out of our max hunger, that gives us a number between 0 and 1 for our hunger. And if we do the same for thirst, again, another number between 0 and 1. If we add those together, we get the total. So if this hunger was 0.3 and thirst was 0.4, this gives us 0.7. So if this was 0.3, this is 0.7. 0.3 over 0.7 tells us 0.3 is hunger, and total negative effect is 0.7. So, whatever, 3 over 7th is our hunger, right? 3/7 of this blocked ratio is represented by our hunger. So we multiply that by the blocked ratio to normalize it to this same range. We set it to the hunger ratio, and it's the same thing, just in other terms for thirst. So we now know how much hunger do we have, how much thirst do we have. Very cool. We want to return those values from the function, so whoever calls this function can use them. So we're going to get our effective stamina ratio, we're going to get our hunger ratio, and we're going to get our that did not go very well. Let's try that again. I dragged it into the wrong pin by accident. They renamed it. Add return node. So effective stamina ratio goes into the first part, hunger ratio goes into the second part, and the thirst ratio goes into the third part. So we're returning these 3 ratio values from the function, so anyone who calls the function can use it. Now we can create the widget for the stamina bar. The widget is going to be owned by this actor component. We're going to create the widget later when we've actually made it. On event begin play, we're going to create it over here, and it's going to be owned by the stamina bar. So we know that the widget can sort of tap into this calculate bar ratios function whenever needed, and that's how the widget is going to get those ratios. We're doing it on the component and not on the widget itself, because the widget is not supposed to know about these values. The widget has no responsibility over these values. All the widget does is it displays whatever it's told to display, but the widget doesn't need to actually calculate those things itself. It's a widget. A widget isn't made for doing calculations, it's made for just showing things, and it's expecting to be inputted with data. Now, all I've said about expecting and supposed to and all that, that isn't a concrete rule. It's just, I guess, good design. You don't have to do that. You could have had this function on the widget itself, but that's just not correct design, because widgets don't need to know about that. And then if you want to find out about those values in another place, it's a lot harder to move them over. So if we put them in one central place, all is well and good. If we go to a content browser, go to Unified Stamina Bar, right click, not blueprint class this time, nope, we're going to search for widget in the search bar, widget blueprint, use a widget, and call this WBP underscore unified stamina bar, and open this up. Very nice. We're getting near to the end now. We're going to add a canvas panel to this to start with. The canvas panel means that this is a representation of the player's screen. So if we place something in a specific location on the canvas panel, then the widget will always be displayed in the same place on the user screen. So I want to now add a size box to the canvas panel. I'm going to anchor it to the bottom right hand corner, set the Y position to 0, set the size to 500 on the X, 20 on the Y, alignment not 0 there, 1 on the Y so it comes up, and I'm just going to add a little bit to the left and make it move up a bit. I skipped over quite quickly how I made those specifics for the size box. Essentially the position X and Y obviously changes where it is on the screen. You can move it around. The size, well, that's just the size of the box, isn't it? By 520. They're the sizes. Alignment, by default, a widget is aligned in the top left hand corner. Now what that means is the 0, 0 position is in the top left. So if I set the position to 0, 0, and the alignment is 0, 1, the 1 means we've moved it 1 above, so the alignment is now in the bottom left. This isn't actually like the alignment of the widget, that's just representing where we've anchored it, which is to the bottom right, but it's aligned to the bottom left. So the location is relative to the alignment. And if I put it on 1 on the X, we're shifting it to the bottom right, which means all of the position is relative to the bottom right hand corner. Or if I put 0, 1, 0, then it's to the top right. But obviously in this situation I want 0, 1 for the alignment in the bottom left, so it's on the inside of the box. I'll just move this into a slightly better position again. There we go, nice bottom of the screen. Now we're going to add a horizontal box to the size box so we can stack things horizontally, which means everything we put in the horizontal box will be squished to be made to fit into this one horizontal box of a fixed size, which is perfect for what we're doing. It's perfect for what we need. Now on this horizontal box we need 3 size boxes, 1 for each section obviously, so we'll have a size box. We'll add this. This will be called SB underscore stamina section. I'm going to set it to a variable, and then I'm going to, what is going on? Duplicate it, and I'm just going to call this SB underscore hunger section. SB underscore hunger section. Finally, duplicate it and call it SB underscore thirst section. There we go. If you've worked with widgets before, you may be very familiar with this, and you may know that usually when you create a horizontal box, you'll press fill. Do not press fill. That is very important because we're going to manually override the width and height override. So on each of these boxes, click width override and height override. So tick these boxes on all 3. We could have done this on the first one and it would happen when we duplicated. Oh well. Make sure all of them have width and height override selected, and they're not on fill. If you have them on fill, you cannot manually override these values in the blueprint. So have it on auto so we can update them ourselves. On the first size box, we're going to add a progress bar. Because the stamina section is going to be represented by a stamina bar. So the fill color and opacity, we can put, it's going to fill as green, and the style, the background image, let's just put this like a sort of gray color. Doesn't really matter. You'll see, you can make it look better if you want, but I'm just obviously showing you how it works. On the hunger section, I'm just going to add an image because I want to just have a solid block of orange color. Image, set the color and opacity to orange. And on the first image, I'll just add another image and set this to blue. Obviously, when you're adding this to your game, you might want to get actual images, actual UI indicators, things that look nice, but I'm just showing you how it is supposed to work. Now let's go to the graph, and we need to make some variables. We need to take certain inputs, we need to have variables. First, I'm going to make a category called sections for the different sections of the stamina bar we have, just to make it look a bit cleaner. On images, I'll make another section called images, and progress bar, I will make another category called progress bar, just so it looks a bit cleaner, because when we add some more variables, it's gonna look a little messy. We need to first of all have a variable called total bar width, and this is of type float, and by default we're going to put it to 500 because the width override, compile save, the width override of this total horizontal box bar, or rather the width of it on size box, is 500. So we know it's 500 on the X, we don't care about the Y, 500 on the X is 500 long. So the total bar width is 500. That is important, we need it on that. We then need to take in something, we need to take in our current stamina, and we need to take in our max effective stamina, and both of these variables need to have instance editable and expose on spawn clicked to true. This is because when we update our progress bar, we're going to update it by our current stamina divided by our max effective stamina, so we need to know what those values are so we can show, you know, how much of our stamina do we have. This is simple stamina bar stuff now, you might have seen if you've seen other tutorials. And we need to take in the ratio for our max effective stamina, our hunger, and our thirst, and these all also need to be instance editable and exposed on spawn. So you'll see how that works, but it just means when we create the widget, we can input a value to them straight away. I'll show you how that works when we create the widget, but for now, just remember, you have to tick these two boxes. Of course, if we duplicate them, it's done automatically. So duplicate that and call it max effective stamina ratio. Duplicate this and call it hunger ratio. Duplicate this and call it thirst ratio. I'll make a new category called ratio and add that to it. Compile and save. Very nice. Now we need to make one function on the widget, which is going to just take in all these values and, you know, show what we need to show based on what we've got, I guess. You'll see exactly what I mean in just a second. So we're going to make a new function. We're going to call it update unified stamina bar. This function is on the widget itself because it's going to update the properties of the widget. It's going to take in some inputs. Actually, we only need one for now because if we set it to float, then the other ones will be float. So I'm going to call this stamina ratio. Oh, let's make sure. Camel case. Camel case just means every new word is a capital letter, but you don't necessarily need the space. I usually do it when I'm making new variables. Stamina ratio of type float, and then we'll make a new variable called hunger ratio. Not really a variable, is it? It's an input input variable, hunger ratio, and then one called thirst ratio, another one called current stamina, and finally max effective stamina. You'll notice that these are the same things we just created as variables, inside the widget. So we've got those variables, compile and save, very nice. I'm going to add a sequence with 2 extra pins, so pins 0, 1, 2, 3, and 4, because we're going to do some extra logic. So what do we need to do? Well, we need to get our stamina section, which is the size box for the stamina part of the box, and we want to set the width override. Set width override. So we'll just drag this up here, and the width override is going to be our stamina ratio multiplied by our total bar width. Multiplied by total bar width. So this ratio, we're using the ratio now to actually, say this is how much of the bar it is. Our total bar width is 500. So if our stamina is supposed to take up 40% of the bar, then 40% times 500 is going to be our width override. So it's going to show, 40. I also want to do a little check afterwards. We're going to say less equal to 0. So if the ratio is less or equal to 0, and we can do this check after we've done this multiplication, because we know anything times 0 is 0. So if this is 0, this will always be 0. So that's why we don't have to check if the ratio itself is 0. We can check if the ratio times by the total bar width is 0, because it's still always going to be 0. That's how maths works. Then afterwards, we're going to do a branch, and we're just going to set the visibility to either visible or hidden. So drag in the stamina section, say set visibility. If it is less than or equal to 0, it's going to be hidden. And if it isn't, then we're going to copy this, paste this down here, and we'll set this to visible. Then we can pretty much just duplicate this twice. So Control C, Control V, plug this into the second one. We don't want the stamina section. We want to do, the next one is the hunger ratio. So plug in the hunger ratio into this value here. Get the hunger section. Control C. Delete these stamina sections, Control V, plug them in, very nice. Then we can just probably move this up a little bit, Control C, Control V, and do the same thing for thirst. So plug in the thirst ratio, delete these 3 widgets, because now we want to plug in the thirst section. I'm just double checking that I did put in stamina, hunger, very nice. Thirst, and then thirst. This 4th one is for updating the progress bar on our stamina, because we don't just have like the size of the stamina bar, we have a progress bar in the stamina bar to see how much of it we need to fill up. So down here at the bottom, we will get our progress bar, stamina progress bar, drag off this and say set %, plug it in on the 3rd pin. And we can just say get current that's not the one we want. We want this one, our current stamina from up here divided by our max effective stamina. Plug in the %, compile and save. Now back in our event graph on event construct, we need to do the update unified stamina bar. And this is why we did all these variables as instance editable and expose on spawn. We can plug all of these values in very easily, because we know whenever we create this, we are going to input these values. We don't have to, that you can still make the bar without doing it. But you know, okay, I'm talking whilst I'm putting in the ratios. Let's make sure we do the right ones here. Okay, so in the first pin, the stamina ratio, we want the max effective stamina ratio, hunger ratio for hunger ratio, thirst ratio for thirst ratio, current stamina for current stamina, and max effective stamina in the bottom one. Very nice. I nearly got that in the wrong way around. That could have been annoying, because obviously I would have had to debug and try and find out what the problem is. Compile, save, go back to our actor component for our unified stamina bar. And now after this stamina tick on event begin play, we're going to drag off to the side and we're going to say create create widget, and then in the widget type we're going to say WBP underscore unified stamina bar. Move that out of the way for my room. Aha, that's what expose on spawn means. It means we've spawned it in and we've exposed the variables. So now we can update the variables for the first time when it is spawned in. But you will notice we don't have all of these values. We've got the current stamina. Easy, right? We go to our stamina, we can say current stamina, plug that in. Max effective stamina, cool, we have that, max effective stamina. But our hunger ratio, thirst ratio, effective stamina ratio, well, we need those, right? We don't have those yet. But fortunately for us, we have a function we can use. Plug in the function for calculate bar ratios, effective stamina, max effective stamina, hunger to hunger, thirst to thirst. Very nice. And then we also would like to promote this to a variable, so we can reference it later. So promote this to a variable called unified stamina bar. Very nice. And then add it to our viewport. We know that when we add it to our viewport, it's going to be in the bottom left hand side of the screen because we used a canvas panel, which means it's always in the same part of the screen. Highlight this, comment it, and just call create unified stamina bar. Show bubble when zoomed, color bubble. Very nice. Now this only shows it when we've started the game. So we need to make sure every single time that we update any of our values that we also change it. Now, very, very fortunately for us, we have a function that we already call every single time we do that. So we go to start update, and we're going to drag in our unified stamina bar. We're going to right click and convert it to a validated get. So I did that a bit quick there. Let's do that slower. Drag it in, right click, and at the bottom, you can convert it to a validated get. What this does is it will check if the variable is valid or not valid. In other words, have we actually created the unified stamina bar or not? We're doing this just to double check because like if it's the very start of the game, there is a chance, you know, when your functions are running, you might get a little error because of this hasn't fired yet before you're trying to update something, and you might try and update your hunger or something before you've actually created the bar because this is at the end. So just to make sure, just to double check, be extra safe, have this validated get, drag in calculate bar ratios, and well, actually we can just copy and paste this. It's this, no, not that one. We can copy and paste these values. Yes, so calculate bar ratio, start update, paste that in. That made no difference. I did not at all need to do that. It's been 2 hours. I'm getting tired now. Fortunately, we're near the end. Right, drag in our unified stamina bar, and we can say update unified stamina bar, and we can now just plug in the values: effective stamina ratio, hunger ratio, thirst ratio, current stamina, max effective stamina. Very nice. Compile and save. Now if we run the game, so go to our level, press play, you can see the bar in the bottom left hand corner. If I press R to increase our thirst, you can see our stamina bar going down. You see every 5 seconds our hunger increases, so you can see how our hunger is increasing. We're going to press H a bunch, so on the next hunger it will increase by a lot more. There we go. If I press T, it's going to decrease that, and I can just play around with the values now. Press T, press R, just press H to make sure the hunger goes up a lot, and you know, J to decrease the hunger. R, you can see all the bars, they're all moving together, because they always have to be a ratio in that bar. The size of the bar always is the same. The max value of the ratio is always 1, so they're never going to be larger or smaller than the bar itself, but they're always going to I guess change shape and morph themselves to fit the bar. So yeah, that is that is the system done. Took a while to do, but you know, good things take time. Hopefully you enjoyed the video. Yeah, if you want to get the completed project files with all the comments, it's on my Patreon. And you know, if you like the video, make sure to subscribe. This is going to start as a Patreon exclusive video, but I'm planning on putting this on Patreon, waiting like a month or something, then putting it on YouTube. I think that's what I'm going to do. So if you're seeing this on Patreon, thank you for being a patron. If you're seeing this on YouTube, why not become a patron? Then you'll see videos like this like a month something early. This is going to go on Patreon a lot before it comes on YouTube. So you get the project files and you get to see the videos early. Yeah, this video was requested specifically by one of my patrons, and obviously my patrons, they have a lot more weight in, you know, my decision making when it comes to new videos. So if you too, I'm not saying I will make a video specifically for everyone who asks, but if you want to have more influence and if you want to have more of an input into, you know, what I'm going to do for my next videos, if you want to, you know, discuss it with me, make sure to become a patron, then you'll have more influence. Other than that, thank you for watching.